So this is the example we are going to look at. If you try to solve through the separation of variables method, it's almost impossible for us to separate y and x. And if you're going to look at the integrating factor method, you won't be able to do it because it's not of the general form y prime plus p of t times y is equal to q of t. So since it's not possible to solve by the methods we know so far, we are going to try if it is an exact equation or not. From the general form of an equation, which can be considered as an exact equation, so we're going to compare these two terms, and we can find that 2xy would act as our n, and 2x plus y squared would be our m for this equation. So what we do is we take m and we're going to partially differentiate it with respect to y. And when you do that, what happens is our 2x term would just drop off. So we would have my as just the differentiation of this, so it will be 2y. Similarly, if I'm doing nx, my x term would be differentiated and the remaining 2y just stays, so it will be 2y. So since my my is equal to nx, therefore this is an exact equation. The next step of it is to solve for the solution or for psi. So we start off with m, which is equal to psi x, and that's equal to 2x plus y squared. So I'm going to integrate this with respect to x. So I'll get psi as x squared plus x times y squared, because over here y would just remain as a constant, and when I'm integrating with respect to x, I would get that. And I need to involve a constant in it, but what I'm going to do is I'm going to do it for the next integration which I'm going to perform and just give it a common constant. So I'm going to take n now, which is psi y, and that is equal to 2xy now. So if I'm going to find psi from here, I would be getting that as the integral of 2xy with respect to y. So 2x would remain as a constant for me, and y would become y squared over 2. So I would end up with x y squared. And I'm going to involve the constant over here. And think about the constant. Since you're partially integrated with respect to y, right? So we're missing out the x terms. So a function of x has to be involved in our solution, right? So it'll be h of x. So now what I can do is I can compare these two terms and say that my h of x would just be my x squared. Okay? So since the two psi equations tally, I can give my final psi or my solution psi of xy as x squared plus xy squared, and over here I'm going to involve the constants that I missed out. If there was like in the partial differentiation with respect to y and x, I would have missed out the constants that was involved in it. So I need to involve that when I integrate. So I'm just going for a plus c at the end. Okay, so this would be my final answer to this exact equation. This is just one of the methods of solving it. There's also another method which is slightly more easier, and I would be doing that in my next video. Thanks for watching.